The Overview tier was created to house a collection of instructional videos. Their unique search code starts with the prefix INST. As we scroll through the View Answer tab, the screenshots of each build from their videos is revealed, so we can see the notes and worked examples which are presented during the video. The instructional videos have been carefully prepared and cover the various curriculum topics. They do go into considerable depth. Here we have some notes on surds, counting combinations, best buy, exchange rates, and expanding 1, 2 and 3 pairs of brackets. Next we can see material covering quadratics with regard to factorising, recognising the difference of two squares, and understanding the role which the discriminant plays as to whether a quadratic can be factorised. Proof is another area with comprehensive notes and worked examples. In this example, we're told a car moves from rest, and the graph gives information about the speed, v meters per second, of the car t seconds after it starts to move. Now, in part A, part 1, we need to calculate an estimate of the gradient of the graph at t equals 15. So I've drawn a blue line which is tangential to the curve at t equals 15, and I've chosen two suitable points on the blue line, and I'm going to use these to work out the gradient of the blue line and therefore an estimate of the gradient of the graph when time is 15 seconds. So the points I've chosen are 4.5, 10 and 20, 22. Therefore the gradient of the speed time graph, which is going to give acceleration, is equal to 22 minus 10, that's the difference in the y coordinates, over 20 minus 4.5, that's the difference in the x coordinates. And this equals 12 over 15.5, which equals 0.77 meters per second squared. And for A part 2, this represents the acceleration of the car. For part B, it says work out an estimate for the distance the car travels in the first 20 seconds of its journey, and we need to use 4 strips of equal width. So you can see that on the diagram I've labelled the shaded regions A, B, C and D. Now, region A is represented by a triangle, region B by a trapezium, and also regions C and D are also represented as trapeziums. And we work out the area of each one and then add them together. So the area of A is a half times 5 times 4, which equals 10. The area of B is a half times 4 plus 12, that's the sum of the lengths of the parallel sides, times 5, that's the distance between them, so the area of B equals 40. And in a similar way, the area of C is equal to a half times 12 plus 18 times 5, which is 75. And finally, the area of D, a half times 18 plus 20 multiplied by 5, which equals 95. Therefore, the distance, which is the total area of A, B, C and D, equals 10 plus 40 plus 75 plus 95. So that's 220 meters.